Welcome to our webinar on AI for insurance leaders. I'm Kevin Sanborn, and I lead the strategy and business development efforts for the Institute in Insurance and Financial Services, and I'll be your host today. So what is the Institute for Experiential AI? It's essentially all things AI at Northeastern and includes over 90 core and applied faculty across 9 disciplinary colleges, over 50 research scientists and postdocs, and focused practice areas that include insurance and financial services, healthcare and life sciences, responsible AI, which focuses on ethics and the use of data and AI modeling, and our climate sustainability practice. Here at the Institute, we believe that successful AI is not set it and forget it, but to create real impact, AI must prioritize the human experience and utilize a human in a loop to constantly evaluate a model's performance and improve its outcomes. We also believe the biggest breakthroughs in the art and science of AI have come and will come through applied projects working with real-world data, generating tangible business results. So I'm just going to take a minute to go through our agenda for today, and then we'll get into the meat of discussion. So first, we'll be joined by Dr. Usama Fayyad, our Executive Director, who will give an overview of the use of AI and data in the insurance industry. He'll then be joined by David Messinger from the actuarial team at Sun Life to talk about a case study on a project we worked together with Sun Life on. Then we'll hear from Dr. Ricardo Baez-Yates, who co-leads our responsible AI practice, talking about the importance of responsible AI governance in the insurance industry. And then lastly, we'll hear from Arup Ganguly, who leads our climate and sustainability practice, talking about the effect that climate change has had on extreme weather and the value and importance in AI modeling in helping insurance companies manage climate risk. And then we'll leave a few minutes for Q&A at the end. And with that, I'll hand it over to Usama.
Thank you, everyone, for joining us. I'm going to cover in my part an overview, as well as I have the honor of welcoming our guest, David Messenger from Sun Life. Very quick background, my education is in AI and machine learning from the University of Michigan, Ann Arbor. I worked on these topics at very large organizations like NASA JPL, Microsoft. My second startup got acquired by Yahoo, where I became the industry's first chief data officer there. I also worked at Barclays as their global chief data officer. Also had my share of startups and consulting companies, so have experiences in both worlds making the technology work. What I'd like to start with is kind of the why. Why has this been getting a lot of attention? A lot of the digital transformation has focused on workflows and little advance on things like customer experience and other areas. So in the front office, there's a need to scale the human intelligence, understanding the context, what is the intent of a customer, be they a consumer or a business, how do we reduce the cost of customer service, cross-sell, upsell, reactivation, all of that good stuff. In the back office, it's still expensive, complex, and needs a lot of intelligence automation. This involves compliance, claims processing, operations, etc. And then there's the new frontiers, going beyond what the humans can do in terms of servicing capabilities. So step counters, for example, linked to insurance risks, tracking safe drivers, driving and drivers with IoT, leveraging networks, social and otherwise, to embed financial transactions, contracts, and so forth. Why is it necessary? Well, as you digitize, you need machines to help you scale. AI algorithms are the only feasible approach to deal with understanding of context and customer. We have to leverage human judgment in the delivery of these solutions to build the right training data sets and knowledge bases over time. We'll talk about the importance of data and the need to make sure AI algorithms are subject to responsible AI criteria. Of course, the complexity of the products themselves requires reasoning, understanding, challenges in AI, multiple ways of recognizing identity is another example, right? Can you rely on beyond the biometrics and other signatures and so forth? The new capabilities in the technology and the network require automation, right? Novel risk and credit scoring opportunities, integration into microservices in the economy. Think about contracts, micro transactions being insured, leveraging networks, easy social networks and other vital services, modeling risk, and future scenarios are better suited for algorithms often with human judgment. New ways of scoring risk and credit, leveraging all the information available publicly, and better understanding of behavioral data. In terms of the big challenges, of course, there's fairness and bias in algorithms that can have huge consequences. Financial decisions are much more consequential than just targeting ads, for example, or writing an essay. Algorithms have little common sense reasoning, if any, and typically all they know is data, so there's a huge dependence on that, and modeling complex decisions and consequences is still a very hard problem. In addition to the advances in technology to enable potentially deep and inappropriate intrusions on privacy and civil rights, and Ricardo Baeza-Yates will talk about some of these things. Now, successful AI is heavily dependent on data. Good training data is extremely expensive to get. Just collecting and managing the raw data is a challenge in and of itself, let alone the exponential growth with the new technologies and Internet of Things and so forth. And finally, data manipulation is very difficult and few understand unstructured data. Most work is on structured data, and a lot of the action in AI is unstructured data. By the way, something that's in the news a lot, ChatGPT, in case you didn't realize it, there's a lot of human intervention in that. We have a whole webinar dedicated to understanding generative AI and ChatGPT, but we actually think that the human in the loop that ChatGPT uses is a best practice. It is essential. It happens at Google, it happens at Amazon, it happens in kind of many places to capture human knowledge and wisdom when you do that intervention. And finally, curating just the right training data, right? You don't just throw all the data in these models. You need a lot of human curation to make it balanced. A lot of the money that OpenAI spent went into curating just the right balanced and useful data sets. So with that, of course, digital transformation has been happening in financial services for a while. I like to use the quick example of accounting. Accounting of 60 years ago involved big ledgers, a good handwriting, good addition skills in your head. Today, it involves none of that. The job is completely different. Yet, of course, we have more accountants today than we had in the history of human civilization. All that happened is the accounting capability as a business need became democratized, and many more businesses use it in many more settings. Now, that digitization, of course, was crucial for the survival or demise of many companies. Kodak is a great example, a company that went 124 years in existence and very successful, lived through world wars, through the prior pandemic of the Spanish flu, through the depression and so forth, but yet to fail because they failed to embrace digitization, even though they invented digital photography. Same happened to JCPenney as a retailer who did not digitize, and now they're trying to make a comeback again after a lot over a century, 118 years old. Now, we have great examples. Vitality is a program by Discovery Insurance, a great example of embracing digitization and digital, where they basically connected your spend habits, your activity and behaviors with your insurance risk. And that gave them realize a lot of savings as well as good customer experience. Capital One is famous in the credit card industry for leveraging AI in a big way, machine learning and prediction to kind of change the way they do risk and extend credit. DBS is a great example of a bank. You may not have heard of it, but it's the biggest bank in Singapore. In 2012, it was essentially going to go out of business. They embraced digital, they did a transformation, they used a lot of analytics, and by 2017, they became Singapore's largest and most successful bank. Now, AI transformation will supercharge the digital transformation that I was just talking about. It will have major economic impact from AI and from generative AI. Knowledge worker tasks, especially in generative AI, anywhere from 15% on the low end to 80% acceleration, not replacement, but acceleration of the tasks that knowledge workers do. It's a new processes for customer acquisition, retention, servicing, growth, what have you. Leveraging big data and that unstructured data I talk about and the new information sources is key. That involves data on consumers, on customers and businesses and their behaviors, data on the world, e.g. climate and sustainability, as we'll hear from Arup. new ways of risk modeling and assessment. A new generation of risk models and strategies are enabled by leveraging the data and the AI, a new generation of fraud detection and countermeasure, and of course, a deeper understanding of the customer and the world. I've listed here a bunch of them. I'm not going to go through them one by one. I have the categories, you have the slides, I gave examples of them. So anywhere from underwriting, pricing and risk, all the way to new models of the world, as we'll hear from Arup, and of course, responsible AI is key, and we'll talk about that as well. AI has already been transforming digital into smart digital. I use some older examples here because they've been around. Zhong is an example of an online insurance company only, no physical presence, right? Lots of business. Insurance company that's also a hardware company. Neos is an example of this, and you can look up their case study. Digital self-serve buying process. Lapitus made headlines by doing this, and this is way before the generative AI buzz. Now you will see a lot more of that. And of course, faster customized claim settlement. Lemonade is just an example of this one, and you can look up information on that. Very quickly, wrapping up this part, think about claims processing in auto insurance, right? You can basically go from, instead of sending an adjuster and all of that, a user records a video. You, based on previous recording, the app identifies damage and so forth, and may ask for clarifications. A real-time claim is submitted essentially, and in some cases processed in real time. Customer approves the assessment, and you go to the service, and it's all linked through a digital thread with a lot of AI happening here in the decision process. Now, of course, a lot of digitization has been focused on automating workflows, which basically could lose us understanding of the customers. Are they happy? Why are they leaving us? Where are they going? The stuff that we relied on human intervention to kind of guess and realize goes away. And of course, the way you can recapture it is by going back to the data. Quick example here. Kelly goes to her insurance agent and wants to buy new home insurance. Kelly has a good standing with the agency. You sell her a policy. Well, guess what? We could have known, and they do know actually, that Kelly just got married. Kelly just started a new family. Kelly is thinking of buying a new, bigger car. What could they have done? Essentially cross-sell the other services, give discounts, use it to retain and increase loyalty. And this is just an example of many, many examples that apply to business and to consumers. The key here is data. Can you capture it? Can you also capture the unstructured data and leverage it? And how you do that and the technology around that is a whole other topic. At this stage, rather than kind of giving you more examples, I'd rather switch gears and welcome our guest, David Messenger, who's the director at Full Scope RMS, which is a division of Sun Life US, and an associate actuary. So welcome, David, and great to have you here.
Thank you very much. I'm pleased to be here.
So, David, I wanted to start out by asking you a few questions. We did a unique collaboration with you and your group and Sun Life US in general around a problem we were trying to solve. How do you think about that problem, and how does the Sun Life team think about data for that project and the other projects we considered?
The specific problem was related to social media investigations and the amount of time and energy it takes to perform a social media investigation to verify a claimant's health and background status. On its face, it's a fairly mechanical but very human-driven task. And we weren't actually producing a data stream off of that at all, if you would believe it. The human would investigate, they would collect evidence, and then they would submit that evidence as confirmation of a claim. This was an opportunity for us to turn that process into something that was faster or scalable, and also to create a data stream, something that in the future we could leverage more powerful tools on, better AI, better everything. in order to create a very scalable future for that department.
Can you describe how kind of the engagement went between the Institute for Experiential AI and with Sun Life, and the fact that we ended up doing kind of all three components, discovering the opportunities, executing on a solution, and running a course and a learning experience in parallel?
I'd love to. Part of the problem that we were experiencing within Sun Life was a problem of I've failed at more data science projects than I could count. That the subject with the actuaries or the people collecting or gathering the data, and the data scientists don't necessarily interface with everyone else. Insurance is a highly regulated, very complicated product to be selling, and admittedly, there's some hesitancy to lose control over that, thinking that you're giving it over to an AI who's going to make all the decisions for you. So we needed to find a way to dip our toe in and make it so that the experts understand what's possible. The people with the problems can recognize, hey, I've got problems to solve. And the people with control over the data know how to work with data scientists. And so this was a ground up effort to create, first of all, a list of problems. What do we see out there that's opportunity already? See how that process is done. And then pick an opportunity and dip your toe in, have data scientists work on it. That was our social media experiment, but also have our people, our actuaries collaborating with the real data scientists and collaborating with students, which opens up a talent pipeline, upskills our employees to be able to actually interact with data scientists. So we had this very large, all around project that aimed to solve 4 or 5 different things that we knew were problems all at once with one big collaboration.
That's great. And I very much enjoyed actually talking to some members of your team, actually actuaries who joined our Northeastern students in the course that we ran in parallel. Could we talk about kind of the results, and then we'll talk about that educational bit, but can you talk a bit about the results and impact of doing a project in this mode?
So the results and impact, on one hand, we have a solution. We have a leverageable piece of technology that allows us to automate steps of that social media investigation. That's fantastic. And it's creating a data stream for future use. Perfect. On the other hand, we also have a group of people who now know how to interact with data scientists. We have actuaries who have done the work. And we even, from the educational standpoint, we've created a group of students who understand insurance and have worked on a real insurance problem. And we could borrow from or draw from that talent pool in the future. We now know data scientists practicing out in the field who know our problems.
Oh, that's great. And on the educational element of the engagement, the benefit to the actuarial team, how did it impact how they thought about AI, about data science, and how AI could be applied to new opportunities on data?
So on the life and health side of actuarial, much less on the property and casualty, but especially in the life and health side of data, there's a tendency to stick to structured data. We're good with it, our models are built on it, and actuaries are very good with structured data. This opened up an entirely new world of problem solving for us. There are countless data streams and things that come out of claims processing and handling that are unstructured that contain real viable information. And we know it's in there, but we've never had the tools to extract it. We've never known how easy or how hard that would be. And admittedly, our IT teams, they learned, okay, how do we set up an environment to run these tools? How do we create a place for an AI type operation to run, which was completely new to them. There was so much learning, and for the students involved in the class, they came away very much empowered to take a different look at the data we already produce and say, can I use this to solve other problems? So it immediately opened up new possibilities for what we're capable of doing.
I love this collaboration we had because it actually included identifying opportunities, going after and delivering a solution to a particular problem, using that solutioning to do training that benefited both our students at the university and, of course, your learners from Sun Life. Any words of advice to other companies on the value of the solutioning with experiential education being a component?
The value, I would say, for all of the employees who are going to get involved in this is surprising. I would love to be able to find some fairly technical claims people and send them through a similar process. Not just actuaries, but anyone out there should be able to see a problem that AI can be used for, that modern analytic techniques can crack open and really make us more efficient. What I would recommend more than anything else is to give employees space and really say to them, this project, this task, this is part of your job. It's not just one more thing that you do off to the side. Say, learning these new skills and understanding what we can do is important to us as an organization. And we're going to give you the time, space, and energy to really pursue it because we want you to come back with those skills. And that will really create an environment for people to thrive and learn things in.
Thank you. Thank you very much, David, for joining us, for sharing the experiences in summary and kind of the benefits, both in employee retention as well as in education and upskilling the organizational skills. And of course, looking forward to continuing our collaborations. Thank you for joining.
Thank you for having me.
With this, I would love to turn it over to Professor Ricardo Baeza-Yates, who will talk about the responsible AI aspects.
So we'll cover responsible AI for insurance companies. Here is my background. I'm working mainly in responsible AI in industry. I had a PhD in computer science from Waterloo University in Canada. And also have worked in industry, Yahoo Labs, and then I was CTO there. I have some startups. I have involved in nonprofit too. And I'm a fellow of ACM and the HUB. So first, why responsible AI? Maybe you have heard about ethical AI. Well, ethical AI has several problems. First, that we shouldn't humanize the machine, and ethics is something human. The same as justice, trust, and many other characteristics are just human, including, for example, hallucinations. So maybe you have heard also about trustworthy AI, and it's another human characteristic, but has even more problems because we know that AI doesn't work all the time. So why we are asking the user to trust something that doesn't work all the time? As I give many times as an example, if we go 100 years back in time and someone says, I have a new transportation medium, it's called trustworthy aviation, maybe I will never have bought a ticket in an airplane, because if you need to put trustworthy to something, maybe it's because it's not. And then we were putting the burden on the user. And it seems that as people are basically harsher with machines. So to err is human, but that's not true for machine. You can check this book of Cesar Hidalgo and collaborators on how humans use machine that basically show that people look for perfection and see that we are creative. And then the question is why we want things that are better than us. And also, we don't know if we can create things that are better than us because they're learning from us. So before going to responsible AI in the insurance industry, let me give you a very short summary on irresponsible AI. This mainly is automatic discrimination. This may be the main problem in insurance industry, but also you have zero science applications, like trying to infer human characteristics from your face. Non-ethical applications, for example, assuming that we are normal people and then we are like other people and then we don't get something that we deserve because we are considered average. We have many examples of human incompetence. I will not mention examples, but sometimes human error is the problem. We have problems in commerce that we can fail because we don't know the real world and maybe we are not offering the right recommendations to the right people. And finally, also we have environmental impact. And I guess our group later will talk about that. So you can see some problems in this huge database called incident database of the AI. There are about more than 2,000 examples, and these are just the tip of the iceberg that we know. And we have built responsible AI atlas that you can go and play with in our website. But for example, here, if you see where the things are happening, half of the tokens are in China or in the US, in the case of this smaller database called Awful AI. But let's go to the risk that you can find here. So here is the webpage for this database. You see some examples, for example, the famous example of the woman in Arizona was killed by a self-driving car, Uber, and I will talk a little bit about that because that's a very interesting case of accountability, and that's important in insurance. But then if we go to insurance, we have news all the time. For example, here is about racial bias. This is from 2022. Another example from 2021 about racial bias too. Also in Yahoo Money, for example, racial bias in insurance underwriting, and also how insurance can mitigate risk. So this important, people is looking at these cases. For example, another example on Connecticut Insurance Department on how to do annual certification. Also, for example, how cities will change in the processing. So responsible insurance is key for underwriting and pricing models that may be adopted by insurance regulators. I will give an example later. Or could be crucial for how to develop models that don't discriminate. And this also will be crucial, will be the same example that I will mention. There's another problem with people that is noise. And that's very common in insurance industry, especially when humans, for example, do pricing or decide how to continue on insurance or not. And I was using here a classical paper from Harvard Business Review written by Daniel Kahneman and other people on how basically noisy decisions or inconsistent decisions were affecting many industries. And one of the main examples in this article is insurance. He also later published a book in 2021 that extended all these examples. Again, insurance industry is one of the main examples. So one good thing about algorithms is that they are maybe biased, but they don't have noise. For the same case, they always do the same answer, even if they're probabilistic. Similar cases get similar outcomes. This is not true for people, and this is very well known, for example, in justice. Part of this is categorical thinking. Basically, people sometimes invent categories that don't exist, and we have done that in history, like, for example, skin color, economic classes, and so on. We are always inventing classes that don't exist, really, and they're very hard to put the line between them, and these are our cognitive biases. That's why, for example, data is much better because it speaks the truth and doesn't associate always our cognitive biases. And this can be very subtle. So, for example, there is some work from one of our neuroscientists, Lisa Feldman-Maurer, that shows that people, for example, can recognize emotion, and then when we use data labeled by people, we're just rediscovering stereotypes. So we need to be careful with this rediscovering of all our cognitive biases. Now, in the world of AI ethics, basically there are three main values, and the values come from bioethics. These are autonomy, basically respecting our dignity, harm benefit, basically do good and don't do evil, and finally try to be justice. And here in the right, I have these instrumental principles that are used by software and AI in general, things like consent, privacy, transparency, efficiency, auditability, scientific basis, competency, accessibility, accountability, and so on. If two principles conflict, then is when we have an ethics issue. If you don't have any conflict, that typically means that you don't have any ethics issue. Now, in October 4, 2022, the White House, the Science and Technology Office, published this blueprint for an AI Bill of Rights. Although that AI being right, very important, so it's making automated systems work. Why? Because we need to apply this to all systems, not only to AI system, otherwise we will have a loophole. And by just saying that we don't use AI, we don't have to fulfill any regulation. These are still recommendations. It's a blueprint. And here you have the five basically instrumental principles that they want to industry to follow. And this already happened. For example, this year, only a few months ago, Colorado ruled AI and data discrimination in life insurance. So this is the very first specific regulation of the use of AI by industry. Well, I belong to the ACM US Technology Policy Committee that in 2017 published this principle for reliability, transparency, and accountability. But now we published 2022 the responsible algorithmic systems statement, and these are the 9 principles. The fourth, that in yellow, are the new ones, the most important. I was the one behind principle number 1, which is basically that any system should be legitimate. For example, do not have to have legal or ethical issue, and that you can show that benefit is much more than the harm that can be do, and also have to be competent. Competent means not only that you are competent on computing, but also on the domain of the problem, and also you have the administrative competence. So you have the permission from the institution to do it, because some big problems have been because you don't have the permission to do it. And the second, especially said that we need to minimize time. So this is a quick comparison between the ACM principles and the White House. The White House, in some sense, is based on the 2017 version. We didn't know that they were working on this. We published our principles only 3 weeks later. And I would suggest if you need to adopt some principles, try to find which ones of these new LCM principles are the ones that your company needs. You don't need all of them. You need to put priorities and use the best of them that are applied to their business. We have found that although people understand these principles, they don't understand how to put them in operation. So this is a slide that shows how in the life cycle of the system, you need to apply that. So the legitimacy and competence is when you have an idea. Then, for example, there you need to do ethical risk assessment. And then when you go to in design development, you need to do validation and testing. And in operation, you need to monitor this permanently to see, to check if basically you are fulfilling the main principles like transparency, and privacy, interpreting explanation if you need, and also limiting the environmental impact. For instance, you need to have contestability and auditability. That you may need to do an audit audit. We have health companies, insurance companies to do audits on models for discrimination. And when it's done, when you need accountability and responsibility, sadly, it's too late, you need to go to court. So to solve AI ethics issues, we created last year the first worldwide high-level AI ethics advisory board. So these are a group of more than 40 experts from all around the world, very well represented, different cultures, their diversity in all possible senses, and we can receive requests for private consultation on AI ethics issues. What about accountability? It's a typical problem. Who is responsible? Well, when in 2018, the Uber car killed this woman, people said, why they're not guilty? Well, the main reason is that they reached a settlement with the family of the victim in the same week that happened. But also, the state of Arizona learned that the woman was basically watching a video when that happens, so they need to charge the driver, the backup driver, and she was found guilty. She was a Mexican immigrant earning basically minimum salary, so that was not a very just outcome because a vulnerable person suffered basically the accountable for this death. She later published an interview in Wired last year that's very interesting on the real story. So we use a responsible AI model that is shown in this diagram. Basically, we have mainly governance, how to do the playbook, the with the process and people in place. Here, maybe we need to use this AI ethics advisory board. We can also do this for products and projects. Here, we do the ethics risk analysis, the audits, and so on. And finally, very important, we need to train the people. We need to train the managers, we need to train the C-level, and also we need to train the engineers or other statisticians or other people that will apply this knowledge. So thank you.
Thank you, Ricardo. Next, I'd like to introduce Arup Gangley, who leads our climate sustainability practice for the Institute. So Arup is a College of Engineering Distinguished Professor and a Fellow of the American Society of Civil Engineers. He has 25 years of experience, full-time professional experience, spanning the private industry, government research, and academia. Arup's research has spawned 2 U.S. patents and 2 successful startups in AI and data science for both climate and weather. He's a senior member of both the IEEE and the ACM, and has a PhD from MIT and Cambridge, and a bachelor's from the Indian Institute of Technology. Arup, thanks very much, and look forward to hearing from you.
Thank you so much, Kevin. So when Hurricane Andrew upended the insurance market in 1992, Karen Clark launched her startup in Boston called AIR Worldwide. And in that great tradition of San Francisco and California following Boston and Massachusetts, I'm just kidding, 6 months later, Hemant Shah launched his startup called RMS Risk Management Solutions. Initially, AIR Worldwide focused on hurricanes. RMS focused on earthquakes. Then both of those companies started to focus on all kinds of natural hazards. And their successors continue to be the market leaders in terms of independent software companies providing what are called natural catastrophe or NatCat models to translate disaster risk to the insurance sector. Back to AIR Worldwide, they were the first to build natural catastrophe models for the insurance and reinsurance sectors. And this company, which is now part of Verisk, considers hazard intensity and exposure with damage estimation and translates these to insured losses. In the times that we live in, weather extremes are hard to ignore. Just as an example, the New York Times quoted us on climate resilience, specifically the technological and societal solutions that are necessary for rebuilding after hurricane. The Wall Street Journal has highlighted one of our climate startups and how it subsequently monetized or developed a pathway for monetization through bond market. Continuing on to media reports, Newsweek has quoted us in articles ranging from droughts and floods. A recent quote discussed what some of us have been calling global weirding, or the worsening of climate-related hazards, often with a reduction in predictability. Disasters result when hazards intersect with increased infrastructural and societal vulnerability, along with increases in exposure of assets and human life. The scientific literature, as well as global and national assessment reports, have pointed to worsening properties of natural hazards, especially those properties which cause severe damage. Just as a case in point, we have flash floods shown here, and even flash droughts. Bloomberg recently reported a doubling of insured losses owing to exacerbation of extreme weather-related damages. In fact, leaders in the insurance and reinsurance sectors have been calling climate change a game changer for the insurance industry. The lack of consideration of climate risks has resulted in severely overpriced US housing market, according to a recent report in the prestigious journal Nature Climate. No wonder then that the private sector, including leading software companies, have started to develop AI and data science-driven solutions, often coupled with physical models, to manage weather extremes, such as the Flood Hub by Google. A recent perspective article in the journal Nature discussed how advances in deep machine learning or deep learning, combined with process understanding, can improve climate and earth system models and how we use those model simulations. The perspective showed how state-of-the-art climate models, pictured on the left, are being improved by recent advances in deep learning. Of the 4 climate AI examples that they chose, they picked one of our research areas that had previously won the second best paper award in ACM-KDD, the leading computer science venue in data mining. In fact, Usama, whom you just heard, has been actually instrumental in launching this entire data mining conference. Statistical downscaling is known to fill a critical gap in climate and Earth system models, where aggregate low resolution model simulations must be brought to stakeholder relevant scales in space and in time. This is incredibly important for the insurance sector, given the scales of property and infrastructure damage. Traditional methods have major challenges. Our physics-informed and uncertainty-aware AI methods showed early promise in addressing this challenge and have since been adapted and cited by groups worldwide. Our methods augmented a deep learning technique for computer vision called convolutional neural network-based super resolution with climate physics understanding, along with Bayesian methods for deep learning adapted to the kind of non-symmetrical data distributions that are prevalent in climate. These methods and their subsequent adaptation and application by groups around the world suggest that augmented AI methods can indeed fill critical gaps in addressing the challenge of scale from global to regional climate models to the resolutions relevant for the insurance. Water resources and water-related extremes, such as floods and droughts, are critical across sectors, including insurance and reinsurance, especially considering climate variability and change. Our methods in explainable deep learning used climate model simulations and observations to leverage information content in ocean variables, or ocean of data, if you will, for improving regional hydrology projections. Our explainable deep learning approaches adapt traditional AI methods such as convolutional neural nets together with saliency. Water resources planners, for example, when dealing with drought-bellied cycles such as in California, need improved projections of regional water resources, which are interpretable and understandable to be able to inform decisions. These methods can be adapted for weather extremes in general and can be useful for the insurance sector. The lack of predictive understanding of regional hydrology is a critical gap that our methods promise to address with explainable AI, and this was published in Nature Communications. The success of our climate analytics startup RISQ, spelled RISQ from quantifying risk, shows the promise that data sciences can bring to urban or regional climate analytics. The startup was originally funded by NSF SBIR, Small Business Innovation Grants, and by actual paying customers rather than through VC funds. Eventually, as reported by the Wall Street Journal, the pathway to monetization was developed through urban or muni bond market. The success of this Northeastern bond startup spawned from my SDS lab, or Sustainability and Data Sciences Laboratory, shows the value of analytics in socially impactful entrepreneurs. A second startup launched by 2 of my former PhD students who were scientists at NASA after their doctorate uses AI on satellite and remotely sensed data to improve weather predictions beyond the state of the art. They recently won a phase 2 SBIR grant from NASA. The renewable energy sector has been deeply interested in their products. We are collaborating with them in our NASA-funded project on AI-based extreme precipitation predictions for downstream flooding emergencies and river management. While our stakeholder partner for this proposal is the Tennessee Valley Authority, the implications for the insurance sector cannot be overlooked. So we are eager to discuss with you how our new practice in AI for climate and sustainability, or AI for CAS, can help meet your business. Thank you.
Thank you very, very much, Arup. Indeed, amazing and brave new world of kind of understanding climate change to cover what's going on in insurance and many other challenges. I'd like to kind of bring this discussion to an end here by giving some key takeaways, right? AI is becoming an imperative in the digital age, but it's challenging to make work. And the challenges include the fact that human intervention is a must. So you have to figure out a way to have the human and the computer work together, what we call experiential AI. And responsible AI is a must, as Ricardo has mentioned. And I'll point you to prior webinars we've had on generative AI, on the role of using responsible AI correctly and so forth. And another very related prior webinar on wearables and kind of their impact on insurance as well. Another thing is that customer experience is a key business driver in this new world as it changes. I hope you got the theme that if you have no data and you're not capturing it, there is no chance of making AI work for you. And if you can't get AI to work for you, that's a serious risk to your business. Getting the data context and the story right is key. And you must have a way to do it. And we would love to kind of partner with you on getting that one done, both on the data front and the AI front. And finally, from Arup, the climate change is an example of the increasing complexity of the need to model the world with new generation techniques and systems, and of the various aspects that can affect insurance, be it in climate prediction, crop prediction, all sorts of disaster anticipation and what have you that come into play here. Next steps, we at the Institute of Exponential AI, I hope you also got that the theme that we like to work on real challenges to both so that we can learn and you can learn with us. How do we identify opportunities for innovation together? We want this engagement to be useful to you, much like we did with our partners at Sun Life. And we will use it to learn. And then how do we leverage it to upskill your in-house talent and leverage researchers and faculty from our side to drive into the research problems that are so valuable to us so that both parties can benefit. The Institute seeks to work with you to solve real-world problems because we think those real problems are key to drive new research directions for us and drive a new way of experiential training of students and learners. So with that, I urge you to get in touch. And as I turn it over to Kevin, I say to you, our logo, let's AI together. Kevin?
Thanks, Usama. Now we have a few minutes for some Q&A. We had some questions submitted by our audience in advance. And the first question would probably be directed at Usama and maybe David, which is, in which business unit or area of the U.S. insurance industry do you see AI improving insurance companies' profit the most?
Definitely, David and of course, Ricardo and Arup jump in. But I outlined, as I did in some of the slides, there are many, many, many areas, practically every aspect of insurance, back office, front office, new directions. Arup kind of opened up the whole brave new world of modeling the world and understanding kind of how these events evolve and how they might impact risk and risk assessment that go all the way from insurance to how do you price bonds to how do governments respond. This micro and kind of modeling, what I call hyperlocal models at very detailed levels that come in with IoT, that come in with wearables, that come in from many of these technologies are definitely going to change the face of insurance. And we would love to be kind of partnering with you on engaging on some of these problems. I'll turn it over to David, Arup, or Ricardo for any further comments on this.
From my experience, there is so much potential all across the back office operations that there are so many places where you could ask the question of any employee, could you train a teenager to do some parts of your job? And I'm sure they can identify a few things that don't require their full talent and understanding. And all of those problems are suitable for future automation.
Thanks, David. Our second question's a little more technical in nature. And the question is, are reasoning frameworks like chain of thought and tree of thought reasoning the future of AI? Maybe Usama, you can start and others can chime in.
I'll say a couple of words and I'll turn it over to Ricardo. Look, my quick answer to this question, and of course, Auru, is I wish. I mean, currently, you heard Auru talk about convolutional neural networks and deep learning and so forth. And these are the predominant techniques today. Of course, the evolution, I believe, for AI and machine learning is to start leveraging models of the world, to start kind of coupling these higher level techniques of reasoning, of domain knowledge. And Auru, I'll let him expand on this. He alluded to that when he talked about Bayesian learning working along with deep learning. But yeah, I mean, that's the direction we'd like to head in. Today, it's primarily driven by data. So to us, today, the data is the shortcut to get to the quick solution. But the deeper problem, the deeper answers will come from incorporating these methodologies. And I don't know, Arup or Ricardo, if you have more comments here.
Sure, I can start there. So some of you might remember this major floods that we had in Thailand, which had repercussions around the globe, especially, for example, pushing up hard disk prices around the globe, because Thailand used to be a major hub for producing an important and critical component of these hard disks. Now, when I visited some of my friends at the National Center for Atmospheric Research, who are the big climate folks in the US, now they were saying, either we were in Thailand at that point, just happened to be, or, we heard later. Everyone there was used to the idea of Thailand is having droughts. As the water level started to rise, is that boiling frog example. Everyone was, okay, we are managing droughts, so let it rise a bit higher, let us do this. Till that realization dawned that, wait a second, we are in the middle of a flood, right? And then something changed. Now, think of all the things, think of the climate, the hydrology, what is driving that, the engineering, the engineered system, those, the dam operations. What the entire scenario then, which of course needs to build it. If we have to build through understanding of that, we need data science methods, we need AI. We also need the physics and technosocial, models, methods that we have. But then think of this decision process that went into it. In that case, it didn't turn out to be right. In some other cases, wrong decisions at one point, such as, when the Indian Ocean tsunami struck, people realized that. And then next time, based on those lessons learned, Hurricane Fani, which was a major one for India, had much less damage because of certain lessons learned. So all this kind of knowledge is not really used in any systematic, principled way today. That's where, to this question, this idea of reasoning-based systems, idea of incorporating human knowledge, both in the context of physics, biogeochemistry, engineering principles, social science principles that exist, but later in the context of human-in-the-loop decisions, they need to come in. And I would suspect, as Usama was saying, they will come in soon enough, even as we continue to develop on generative.
Thanks, Arup. That's great. Third question we have is for Ricardo. Ricardo, as you've been working with insurance companies in the responsible AI space and have been doing bias audits of some of the different models out there, are there any kind of key themes or learnings you're seeing across multiple models that would be helpful for other insurance companies to be aware of without betraying any confidential information?
That's a great question. Many times the bias that you find these models are completely unintended. It's basically biases that are already in the data, and you need to curate in some sense. But if you don't do only, you only find out when, for example, some customer sues the company, and there is too late. And for example, we have been helping companies to do these audits in advance. So when they have a new model and they want to put that in operation, and we find things that they don't expect. For example, things that are important, for example, like age bias, or for example, bias to certain cares if we're talking about first insurance. Or there are other cases that show in the presentation where they were about the race, because the data has that kind of bias. But important thing too is that it's not only in the data, but it's also on what you are trying to optimize. For example, sometimes the models are based on data that depends on certain events, but they are trained in one type of event, but they're trying to predict another type of event. So they have a mismatch, and they didn't realize that until it was too late. So we can help the companies on basically finding all these issues to have a model that is not only correct, but it's also responsible.
Thank you. The next question we have, I think, could be to any one of our speakers today, which is please share the data sources that are used for different kinds of analysis. And my guess is the answer is probably everything, but open that up to anyone to chime in on.
In terms of which data sets can be leveraged, I mean, my answer being a data guy is all data can be leveraged. And in many cases, we find that people haven't even thought about the fact that that data is there and can be leveraged in their context for their business. David?
It's that last part that you said about haven't even thought about it. In some cases, there's thinking about what data is available. And in other cases, there's also looking critically at your business operations and saying, where is there data that's being handled and sort of just thrown away or stored in a place where, or in a fashion where it's not usable in the future? So much of what you do could create data, and you may not even necessarily notice or be thinking about it.
That's a great point. In fact, I mean, even simple stuff like responses to RFPs historically. Companies who don't do AI don't think about the value of such data. Other companies, the ones who are deeply into AI, whether it's a Google, an Amazon, a Microsoft, a Open AI, et cetera, they understand this and they try to capture. And typically, they're so hungry for data, they're trying to capture every aspect of it. Arup, looks like you wanted to say something here.
Well, I mean, I think between David and Usama, both of you have mentioned all of the aspects. But of course, there are model simulations, there are observations, there are these kind of transactions, there are decisions, all of which need to be mined and from which we can get various information. Just wanted to mention a couple of things. One is there is often data out there, open access, which can be creatively used to address various problems. So one is open access, one is what David already mentioned, all of these data sets in your own corporation, which trained individuals can start to use. The second point I want to make is, even as we are thinking about AI and machine learning, and as I think Usama said in his talk, that without data, there is no machine learning, and we are usually talking about big data, large data. But do not underestimate the value of small data where we have them. Some of them could be incredibly useful data, whether it's data about rare events or extremes. And as they say, any extreme or disaster is a terrible thing to waste in terms of lessons learned. Or whether it's data in some periods when, or some regions where the instrumented record is there, but not that much, they can add substantial value, both in AI and machine learning models and broadly in data. There's a wide variety of data.
The comment I made earlier, which is a lot of the resources spent by, say, an OpenAI or by Google, et cetera, is about labeling that data. Think about all the work happening in your organization where you actually have experts, extremely deeply knowledgeable experts doing stuff, making decisions, but you're not capturing that data. Sorry, Ricardo, I interrupted.
No, I wanted to stress what Arup said about small data. In many problems, we will never have big data, so we need to use small data. In that case, maybe deep learning would not be the best solution. And we need to leverage other machine learning techniques that are great, and they're also many times more interpretable and more explainable than deep learning.
Thank you all. I think that's probably a great question to land on. I think we're probably out of time at this point. So thanks again to all of our speakers. Thanks to all of you who attended. As Usama said, that we here at the AI would love to partner with you on your AI journey. So please reach out to us, and we'd love to talk to you about your most challenging data analytics problems and how we can help. So thanks, and have a great day.
Thanks, everyone. And we will answer any questions we didn't get to online.